Hello geometry students. In this video we're going to take a look at our 4.5, 4.4 and 4.5 notes. And I like this lesson because this is the lesson where a lot of students start seeing a lot of success in writing proofs. So let's go ahead and get started. We're actually going to start with a great big giant proof here. What we're going to prove is we're given all this information. We're going to prove that triangle PQS, that's the yellow one over here, is congruent to triangle RQS, which I've colored blue. Okay, so how are we going to prove two triangles congruent? Well, right now, the only way we know to prove triangles congruent is to use the definition of congruent polygons, which says two polygons are congruent if and only if all of their corresponding angles are congruent and all of the corresponding sides are congruent. So since a triangle has 3 angles and 3 sides, in order to prove these two triangles congruent using that definition, we're going to have to show that there are 6 pairs of corresponding parts congruent. Well, fortunately, we have plenty of information here to get that done. So let's get busy proving that these two triangles are congruent by showing that we have 3 pairs of angles congruent and 3 pairs of sides congruent. Okay, so what I'm going to do, we have a lot of given information, and of course you are certainly welcome to list all that given information at the beginning of the proof, but I like to take it one piece of given information at a time. So let's go ahead and start with our first piece, which is this one, that segment PQ is congruent to segment QR. Okay, so our reason for that is because we are assuming that that is true. It's given to us. All right, so what I'm going to do over on the left side of our proof is I'm going to kind of keep track of, remember we have to get 3 pairs of sides and 3 pairs of angles congruent. So I'm just going to keep a running list here. I'm going to use S for side and A for angle. And once we have 3 sides and 3 angles listed, we know that we have satisfied the definition of congruent polygons. So let's move on to the next piece of given information, and that is that S is the midpoint of segment PR. Oh, by the way, let's go ahead and also, as we prove things congruent, let's go ahead and mark them on the diagram. So we have established that PQ is congruent to QR, so let's mark that on the diagram. We have PQ congruent to QR. Okay, so our second piece of given information is that S is the midpoint of segment PR. Okay, so I'm going to check that off and write down our reason. That reason is given. Now, how is that going to help us? Well, if S is the midpoint of this segment, what do we know about midpoints? Well, the definition of midpoint says a segment is a midpoint if it divides a segment into 2 congruent pieces. So that will give us another pair of congruent sides. So let's go ahead and say then in step 3 that segment PS is congruent to segment SR. Okay, the reason that is true is definition of midpoint, which as I said earlier, definition of midpoint says a point is a midpoint if and only if it divides a segment into 2 congruent pieces. So we can go ahead, now that we've established that, let's go ahead and mark that PS is congruent to SR. And I'm also going to just make a note that we have another pair of sides congruent. Okay, so moving on to our next piece of given information, that segment QS bisects angle PQR. So here's QS, and it is bisecting PQR. So let's go ahead and list that. Segment QS bisects angle PQR. Okay, that's a piece of given information. Now, the way that helps us is because what does a bisector do? What does a bisector do to an angle? It cuts an angle into 2 congruent angles. So let's go ahead and label these angles. Let's call this one angle 1 and this one angle 2. So because of that angle bisector, we can now say that angle 1 is congruent to angle 2. So let's mark it on the diagram. Okay, and let's write a justification. The reason why angle 1 is congruent to angle 2 is because of the definition of angle bisector. Okay, so back to our list. That means we have now 2 sides and 1 angle, so we're halfway there. We have to prove 6 pairs of corresponding parts congruent. So let's go ahead and keep moving on to our next piece of given information. So let's see, we've used this one, that QS was a bisector. Let's move on to the next piece of given information, and that is that angle P is congruent to angle R. That is given. We are assuming that to be true. So let's mark it on the diagram. We have angle P congruent to angle R, and then I'm also going to add that to my list. Let's see, now I have another pair of angles congruent. All right, and so let's move on to the next piece of given information, and that is that segment QS is perpendicular to segment PR. So QS here is perpendicular to PR, and that's good because perpendicular lines give us right angles, and then of course we know right angles are congruent. So we'll get another pair of congruent angles. So let's go ahead and list that given, that segment QS is perpendicular to segment PR. Why is that true? Because we're assuming that it's true. And now, since QS and PR are perpendicular, well, what do we know about perpendicular lines? We have a theorem that tells us anytime we have perpendicular lines, we have a total of 4 right angles. So I'm going to go ahead and mark those angles as right angles. Okay, and let's number them. Let's call them angle 3 and angle 4. So we're going to say that angle 3 and angle 4 are right angles, and the reason is because of the theorem we proved a while back that says anytime we have perpendicular lines, that implies that we have 4 right angles. Okay, and what do we know about right angles? Well, if you remember, the very first proof we ever wrote was called the right angles congruence theorem that says anytime we have right angles, we can say that those angles are congruent. So we're going to say that angle 3 is congruent to angle 4, and the reason why is because of the right angles congruence theorem. Okay, so let's list that. There's another pair of angles. So now you can see we have two sides and 1, 2, 3 angles. So we just need one more part. If you take a look at the diagram, you'll see that the yellow triangle and the blue triangle share a side. And of course, that side is going to be congruent to itself. So we can say that segment QS is congruent to itself because of the reflexive property. So now if you take a look at our list, we have, we now have another pair of sides congruent. So now if you take a look at our list, we have 1, 2, 3 pairs of sides, and then 1, 2, 3 pairs of angles. So what we have shown through this proof is that all 6 pairs of corresponding parts are congruent. So we have satisfied the definition of congruent polygons. So on our last step, we can say that triangle PQS, the yellow triangle, is congruent to triangle RQS. And the reason why is because we have satisfied the definition of congruent polygons. Okay, so we did it. Now, I have good news for you, and that is that's the last time we're ever going to have to write a proof for proving 2 triangles congruent that will take this many steps. The reason why is because we're about to learn some new tools that we can put in our toolbox. Right now, the only tool we have in our toolbox for proving triangles congruent is the definition of congruent polygons. So what we're going to learn now is 3 postulates and 1 theorem that make proving triangles much, much easier. Okay, what these postulates and theorems allow us to do is to prove, instead of proving all 6 pairs of corresponding parts congruent, we only are going to have to prove 3. So the first postulate is called the side postulate because it says the following. It says if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So let's, over here, let's take a look at these triangles and let's mark them. We're going to assume that we have 3 sides of one triangle congruent to 3 sides of another. So let's mark that. So we have the short sides that are congruent, and then this side, pair of sides congruent. Let's put 2 tick marks on those, and then the third pair of sides congruent. So now, what this postulate tells us is that I don't need to worry about the angles. If I know that all 3 pairs of corresponding sides are congruent, that's enough to justify that the 2 triangles are congruent. We won't need to use this definition of congruent polygons anymore. So The shorthand way that we'll write this postulate is we'll just say side, side, side implies congruent triangles. Okay, that's called the side, side, side postulate. Okay, this next postulate is called the side, angle, side postulate. And it says if two sides and the included angle, we'll talk about what that means in just a second, if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then that's enough to justify that the two triangles are congruent. So let's mark what we mean by two sides and an included angle. So let's mark two sides congruent. So how about these sides and these sides? Okay, so we have two pairs of sides congruent. The next thing we need to mark is what we call the included angle. So if you look at this picture, the included angle is going to be the angle that the two sides form. So in other words, this one is not the included angle, and this one is not the included angle. The included angle is this one. Remember, it's called the side, angle, side postulate, so it'll kind of look like what it sounds like. So we're going to go ahead and mark this included pair of angles congruent, okay? And what this postulate guarantees is that, again, we don't have to worry about the other pair of sides or the other two angles. Side, angle, side is enough to guarantee that the two triangles are congruent. So two sides and the included angle of one triangle congruent to two sides and the included angle of another triangle guarantees that the two triangles are congruent. Okay, the shorthand way that we'll write this postulate is like this. Side, angle, side implies congruent triangles. Okay, the next postulate is called the angle, side, angle postulate. What it says is if two sides and the included angle of one triangle are congruent to, I think I read there are, I'm sorry, if two angles and the included side of one triangle are congruent to two angles and the included side of the other triangle, that's enough to guarantee that the two triangles are congruent. So let's mark what we mean by angle, side, angle. That would be two angles and an included side. So let's mark two pairs of angles congruent. How about this pair of angles and this pair of angles? Okay, so now what do you think the included side would be? Well, the included side is going to be the side that the two angles have in common. So, or the side that the two angles share. So that would be this side. You'll notice that if we were to highlight both of these angles, this would be the side that got highlighted twice. Okay, so we'll mark that pair of sides congruent. Okay, so I just want to point out that this is not an included side and this is not an included side. The included side would be that one side that the two angles have in common. So angle, side, angle. Okay. So again, that's enough. We don't have to worry about the other pair of angles. We don't have to worry about the other pairs of sides. That's enough to guarantee that the two triangles are congruent. So the shorthand way that we'll write this postulate is like this. Angle, side, angle implies congruent triangles. Okay, so these three are postulates. We assume these to be true without proof, but this last one is a theorem, so we'll prove that in just a minute. And here's what the angle, angle, side theorem says. It says if two angles and a non-included side of one triangle are congruent to two angles and a non-included, sorry, this blank isn't quite big enough, non-included side of another triangle, then that's enough to guarantee that the two triangles are congruent. So let's mark what we're talking about. Angle, angle, side. So that's two angles and a non-included side. So let's mark the same two angles that we did in the last example. Okay. Now remember, this was the included side, right? So either one of these sides would be the non-included side. So it doesn't matter which one we pick. I'm just going to pick this one and mark it congruent. Okay. So now we have two angles and a non-included side of one triangle congruent to two angles and a non-included side of another triangle. That's enough to guarantee that the two triangles are congruent. We don't have to worry about the other angle or the other pairs of sides. So the shorthand way that we write that theorem is like this. Angle, oops, let me do that in blue. Angle, angle, side implies congruent triangles. Okay, so you'll remember that the angle side justification for proving two triangles congruent was a theorem. So since it's a theorem, we're going to go ahead and prove that. And it's going to be a very short theorem, very short proof, because remember, we don't have to use the definition of congruent polygons and show all the parts congruent anymore. We have now those three postulates in our toolbox, which makes proving triangles congruent much, much shorter. So what we're given is we're given two pairs of angles. Let's go ahead and mark those. We're given angle G congruent to angle K and angle J congruent to angle M. And then we're also told that segment HJ is congruent to LM. So let's go ahead and mark those congruent. HJ congruent to LM. So we're assuming that we have two angles and a non-included side of one triangle congruent to two angles and a non-included side of another triangle. So to get those congruent, we just need to get one more pair of parts congruent that we'll talk about in just a minute. So let's go ahead and start with our given. We have angle G congruent to angle K, angle J congruent to angle M, and we have segment HJ congruent to LM. So now, the reason for that is given. We're assuming that to be true. Now, if I just had one more pair of parts congruent, then we'd be in good shape. If you'll recall from our last lesson, we had a theorem that said if two angles of one triangle are congruent to two angles of another triangle, then we can conclude that these third angles are congruent. That's called the third angles congruence theorem. So we can go ahead and say that angle H is congruent to angle L. Let's mark that. H, I'm going to put 3 arcs on H, is congruent to angle L. Okay, and the reason why is because of the third angles congruence theorem. Okay, so now look what we have. Now we have two angles and an included side of one triangle congruent to two angles and an included side of another triangle. So that means we can use the angle side angle postulate to justify that these two triangles are congruent. So in step 3, we're going to go ahead and say that triangle GHJ is congruent to triangle KLM, and the reason is angle side angle implies congruent triangles. Okay, so these theorems and postulates make proving triangles, oops, I didn't mean to do that, proving triangles much, much more congruent. Much, much shorter. All right, so let's take a look at these examples. The directions say, can you prove that the triangles are congruent, and if so, provide a reason and then write a congruent statement. So we're going to try and get these two triangles congruent. So I'm going to, real quick, I'm going to color one of them yellow and color the other one blue. Sorry if I went outside the lines. Okay, so we're going to prove that the yellow triangle is congruent to the blue triangle. Well, what we have marked is we have one pair of angles and one pair of sides. So that's not quite enough, but I want you to notice these two angles. I'm going to call them angle 1 and angle 2. Notice that they are a pair of vertical angles, and of course, vertical angles are always congruent. So if we mark those congruent, now you'll see that we have two angles and a side of one triangle congruent to two angles and a side of another triangle. So that's enough to guarantee that these two triangles are congruent, but we have to decide, since it's two angles and one side, is it angle side angle or angle angle side? Well, I hope you can see that the side marked congruent is the non-included side. So the reason is going to be angle angle side. So let's go ahead and write our reason first. The reason that the two triangles are congruent is because angle angle side implies congruent triangles. Okay, so now what we need to do is we need to write our congruent statement. So I'm going to name the yellow triangle, I'm just going to call it triangle PQR. Now I can name the first triangle anything I want, but now that I've named the yellow triangle, that's going to dictate how I name the blue triangle, because I have to make sure that corresponding parts match up. So if I'm going to call the yellow one PQR, then let's see if we can figure out what angle corresponds to P. Well, the markings are going to help. Notice that P has one arc, T has one arc. So that means P and T correspond. Okay, oops. P and T correspond. And then Q has no arc on it. Okay, so that means it would correspond to S. And then finally, angle R, which has two arcs. R in the yellow triangle would correspond to, that with two arcs, would correspond to R in the blue triangle that has two arcs. I guess I didn't write down my second vertex. So it's PQR corresponds to TSR. Okay, so let's take a look at this second example. So here I'm going to color the triangles again. Let's see if we can get this yellow triangle congruent to this blue triangle. Okay, so you'll notice that the two triangles have two pairs of sides marked congruent, but that's not quite enough to get the two triangles congruent. However, notice that they share a side, and that side AC is always going to be congruent to itself. So I'm going to go ahead and mark it congruent to itself. So now we have enough information to guarantee that the two triangles are congruent. So, and the reason is going to be side, side. Okay, so I'm going to go ahead and write the reason first. The reason these two triangles are congruent is because side, side, side implies congruent triangles. Okay, so now when we write our congruence statement, I'm going to name the yellow one first. I'm going to call it triangle ADC. So if I call it ADC, and we can call it anything we want, but if I call it ADC, then I need to be careful when I write name the blue triangle that corresponding parts match up. So if I call it ADC, notice we have two tick marks followed by one tick mark. So I want to name the blue triangle. So again, I have two tick marks followed by one tick mark. So how about we call it CBA? That would be two tick marks followed by one tick mark, and then our corresponding parts would match up. Okay, so we have one more example. Let me go ahead and color the triangles again. We're going to get this yellow triangle on the left congruent to the blue triangle on the right. So let's see if we can find a reason why those two triangles would be congruent. Well, what we see marked is we see a pair of sides congruent, and then we see these right angles. Remember, the right angles are congruent, so we just need one more part. Let's use this side that the two triangles share. So let's mark that congruent, and when we do, we can see that we have two sides and an included angle of one triangle congruent to two sides and an included angle of another triangle. So that's enough to guarantee that the two triangles are congruent. We call that the side angle side postulate, and side angle side implies congruent triangles. Okay, so our congruent statement then would be triangle. We can call this yellow triangle anything we want. How about if we call it triangle LKM? So if we call it LKM, then the blue triangle, let's see, LKM, let's see, L needs to correspond to N, and then K in the first triangle corresponds to K in the second one, and then of course M in the yellow corresponds to M in the blue. So we'll call the second one NKM. NKM. Let's finish off with a couple of proofs using these postulates and theorem that we learned today. So in our first proof, we have a couple of pair of sides congruent, and we're going to prove that this yellow triangle the blue triangle rather, ABC, is congruent to the yellow triangle CDA. So let's go ahead and mark what we're given. We're given that side AD is congruent to side BC, and that side AB is congruent to side DC. So that's almost enough to prove the two triangles are congruent. We just need one more part. So you'll notice that the two triangles share a side. That side is congruent to itself. So that's going to give us a third side, and so we can get the two triangles congruent by side, side, side. So we'll start with statement 1. In statement 1, we're going to start with our given, which says that side AD is congruent to side BC, and side AB is congruent to side DC, and the reason is given. Okay, so let's go ahead and keep track of what we have. We have two pairs of sides congruent. We just need one more part congruent, and we mentioned this side that the two triangles share. that segment is congruent to itself. So let's go ahead and mark that. Okay, and in step 2 in our proof, we can say that side AC is congruent to itself, and the reason is the reflexive property of congruence. Okay, so let's mark that down. So now we have 3 pairs of sides. We have 3 sides of one triangle congruent to 3 sides of another triangle. So that's enough to guarantee that the 2 triangles are congruent. So we can say that triangle ABC, the blue one, is congruent to triangle CDA. And the reason is because side, side, side implies congruent triangles. All right, and then in our last example, this time we have angle DAB congruent to triangle CEB. So let's go ahead and mark that. Angle DAB is this angle. So we'll mark it congruent to angle, let's see, angle CEB. So that's this one. Okay, we're also given that side DB is congruent to side CB. So DB is congruent to CB. Let's go ahead and mark those. Okay, so we have one angle on one side. That's not quite enough. We need one more piece of information to prove the 2 triangles are congruent. So I want you to point out these vertical angles. In fact, let's go ahead and number those. Let's call one of them angle 1 and the other one angle 2. Since they are vertical angles, they are congruent. So that's going to give us enough information to prove the 2 triangles congruent. So let's go ahead and write our proof. Let's start with the given that angle DAB is congruent to angle CEB, and side DB is congruent to CB. Okay, that is given information. Okay, now let's keep track of that. So we have one angle and one side. We need one more piece of information. So let's talk about those vertical angles again. Remember, vertical angles are always congruent, so let me mark those. Let's see, we have angle 1 congruent to angle 2. Okay, so angle 1 is congruent to angle 2, and the reason why is because of the vertical angles congruence theorem that we proved a while back. Okay, so now we have enough information. We have 2 angles and one side of one triangle congruent to 2 angles and a side of another triangle. But we have to be careful here. When we have 2 angles on one side, you must look at the diagram and determine, is it an angle side angle situation or an angle angle side. So if you look at, let's look at this blue triangle. We have our 2 angles, and I hope it's obvious to you that this side is a non-included side. This would be the included side. What we have marked here is a non-included side. So that means that these 2 triangles are congruent by angle, angle, side. So in step 3, we're going to say then that triangle ABD is congruent to triangle EBC. And the reason why is because angle, angle, side implies congruent triangles. Alrighty, so you can go ahead and get started on your homework. And if you have any questions, be sure and ask me when I see you next time in class.